Hi everyone. Who do we have here? Hi Al, hi Shubham, what's up? How are you? Crispy, hello, yeah, thanks a lot for joining. Okay, let me check a few things. Let me know if the voice is, proper. We don't have chat in the theme now because of some reasons, which I'll let you know. But then let me know if my voice is coming to you guys properly, if there is any kind of distortion, or if you feel it should be louder. Yes, Crispy, yes. Let's go, guys. Come on. Guys, whoever is joining, please say hi in the chat so that I know that you guys are here. Is this gonna help me to realize when should we start? Yes, that's proper. That's nice. That's nice. Thank you. All right. Come on, guys. Please join the chat and say hi once so that I know that you guys are here. Mhm. What's up, guys? What's up? All right. So, guys, tonight's stream is gonna be a little shorter because I'm not feeling well. So we're gonna stick to maybe 45 minutes or something. But let's see how it goes, okay? I actually was planning to cancel the stream tonight, but then I wanted to stick to my promises that I make. So I'm I'm just gonna stick to the routine. So anyways, I hope that tonight your time will not be wasted. We're gonna discuss some really important topic tonight, okay? Even though the stream might be short, but then the topics are gonna be really, really good, okay? Shubham, you're not feeling well? What happened here? Are you not good? Um, all right. So guys, are you ready? Should we start now? Should we just wait for a few more minutes? Let me know if you guys are ready. We can just start. Uh, just a minute. I just need to. Thanks a lot. Thank you, Lipiti. Thanks a lot. So, guys, I think we might not have a lot of watching tonight. So, anyways, I'm gonna start. Oh, Akshay, thanks a lot. Thank you. Uh, Great to have you here. By the way, it's really nice to have you here. So, anyways, for those who are new, I just want to share what we have been doing all this while. So, I live stream every Saturday and Sunday around 9 to 10 p.m. Right? So earlier it used to be 10 p.m., but now I've shifted to 9 p.m. just for some reasons. And all right, so what we do every live stream is we pick up a project or we talk about a topic and live coding kind of stuff. Because I really want people to understand that development is not that easy and not that tough as well. So whatever you see me doing live, it will really help you a lot to gain experience like debugging and all. So a lot of streamers or a lot of people, what they do on YouTube, you see them writing intense codes, you see them writing really good codes, but then you don't see them when they are actually struggling. So the concept behind this live streaming is, first of all, I really want you guys to understand that nobody is perfect, right? So you will face a lot of errors while you're coding, and I'm just curious enough to solve them. So I'm just going to show how I go forward in solving the errors that I get. Another thing is talk about the intuition. So a lot of people used to come to me and say that how do you get the project ideas, right? And that is what we do. So a lot of times it has happened that while in the live streaming we have talked and suddenly we have got a project idea, right? So a few of the people in the live stream have asked me a question and that was converted into a project idea. So we have done this a lot of times, okay? So I'm gonna stick to that idea and hopefully this will work, right? So I hope you guys like the idea behind this. And for during the weekdays, I'm planning to release some videos, recorded videos of 30 to 45 minutes, just how to implement that project and all in short. So that's going to help for those people who cannot watch a 2 hour long stream when they are not here. So it's going to help them a lot. But since I'm just occupied with work, it's a little difficult for me to get started, but I'm trying to release a video very soon, okay? So I hope this sounds good to you all of you. Whoever is watching, thank you for coming, guys. And just say hi in the chat once so that we can start. Can I just have a hi from all of you? Hey, what's up? Okay, Mohit, thank you for joining. Yeah, thanks a lot, guys. So it's again, I repeat, it's gonna be a really short stream tonight. I am not feeling well, so unfortunately it's gonna be I hope you guys understand. So it's a real difficult thing to keep doing what you are doing and not take a break. So uh, it's just that I hope you guys will understand. So all right, all right. So I think a lot of people are ready to start, and I'm I'm, I'm really happy to see all of you coming all the time, every stream. So I really appreciate that. All right, just let me see. All right, so guys, we're here. Okay. Mohit, what happened? Nothing, yeah, nothing. Let it be. But I don't really want to give negative vibes, so let's be happy. Come on, guys. Okay, we should do this, and I'm gonna talk about what we're gonna do tonight, and it's gonna be really interesting thing, right? So I'll try to be energetic. All right, let's go. All right, guys. So I'm gonna share my screen. I've already shared my screen. I've just opened a guest user so that just for my own privacy reasons. Also, let me quit Discord. Right, TeamViewer as well. I don't think we need that. By the way, is the stream buffering? Is the stream buffering for you guys, or is it like proper? I'm just testing a few new settings. As you can see, like I've installed Ubuntu, so I'm using Ubuntu for streaming now. So just let me know if it's working fine or not. So Nilanjana, it's not buffering, right? So it's good, right? Perfect. All right, so we are good to go then. I've really received confirmation from a moderator, so I think that is a good point to start, right? So okay, let's go to this buffet codes repo. So guys, one of my friends, right? Uh, yeah, sure, Akshat. Yes. So for tonight, what we are trying to do is we're gonna do transfer learning, right? As I told in the previous stream, that whatever we are gonna do is the end goal is to try and write this code from scratch, right? So whatever you see on the screen, we will be writing this eventually live on YouTube, okay? But the steps are gonna be really smooth, right? So today as well, like I'm gonna just show you some tensor manipulations thing, how to create a tensor, how to operate on tensors. Then we're gonna move forward to reading images from a folder. Then we're gonna start deep learning and transfer learning, right? But today I'm gonna talk about transfer learning. What's the idea behind transfer learning? What's the intuition? Because that's the most important part of it, right? So, all right, guys. So, how many of you know what is actually transfer learning? How many of you know what is fine tuning? What's the difference between transfer learning and fine tuning? Do you guys understand the difference? Hi Ashish, thank you for joining. Good evening. What's up? How are you? Um, like yes, please do like if you like the content. Yes. So I'm gonna talk in really brief. Okay, let's do this. Let's get into the chatting mode instead. Um, all right. So I'm in the chatting mode and let's talk about transfer learning and and fine tuning, right? So what happens? Okay, let's talk about this thing. So a lot of researchers in some institute, let's say in MIT, in Stanford, had a lot of data set, right? So they made huge data set of millions of images, right? It's called ImageNet. So ImageNet had 1,000 classes. That means they had 1,000 labels, maybe dogs, cats, tiger, lion, anything, snake, chair, table, car, scooter, whatever, right? So, so they had a lot of things already there. So they had millions of images of total 1,000 classes, right? So there were 1,000 classes, millions of images. They had a huge data set. They trained their model, right? So whenever I say model, understand data that is a set of architecture, or just call it an algorithm, which trains itself, which tries to learn from the data set, right? It tries to understand the features of the images. Let's say, like for example, in face detection, we talked about it, right? That for eyes, the brightness of above the eyebrow will be like very high, and below the eye will be very high, but eyebrows. But then here it will be very dark, of course, because we have hair on it, right? So this is one feature, right? So there's so many features in an image, right, which we can do using deep learning. So eventually, what the algorithm is trying to learn is trying to learn the features from the data set, right? So in ImageNet, we had millions of images. We had the model being trained, a lot of, okay, very deep architecture, right? So, and for that we require huge computation power, right? So we require maybe huge GPU memory. We require maybe SSD, right? No, HDD will be very slow, right, to load dataset. So there's so many things we require. So what the researchers did, they had good enough funding, right? So they were rich in terms of funding. So they had all the resources, they trained their model, and the output they stored somewhere. So now that output can be stored in a file, okay, just like some exe file. For models, we have different formats, right? It can be anything. So we stored the model, right? And that is what we can do later on, that we can just load the model and use it. So we don't need the computation power again. We don't need SDD for that. We don't need huge GPU memory for that. So what they have done is they have trained the dataset, okay, trained the algorithm on the dataset, and they have stored the model in some file which can be reused by other people, right? Now what happens? Okay, let's talk about this, okay? You all have heard about dogs versus cats thing, right? So when a model is trying to distinguish between what is a dog and what is a cat, so if I give it an image, it should be able to tell that it's a dog, it's a cat, right? But what if I'm trying to do something like Jaguar versus German Shepherd, maybe something like that, right? Now what happens is we don't have enough images for that. Maybe we only have 10 or 20 images, or maybe let's say 100 images for Jaguar and 100 images for German Shepherd. Okay, we don't have enough images for both of these classes. So what happens is we can't really train our algorithm on these 100 images because the data set is not enough. You cannot learn features from 100 images. It's just not possible. Okay, because it needs a lot of data set to understand what's happening. So what we can do is we can use the trained model which has already been trained on millions of images, right? And Jaguar and German Shepherd are kind of related to dogs and cats, okay, because of they might be of those breed or something, I don't know, but then they are related, right? So maybe the model which has learned a feature about dogs can be reused for German Shepherd versus Jaguar. Okay, so this is possible. So what we can do is whatever model we have trained, we can reuse it and train it on our dataset. By train, I don't really mean that we have to run it for all the epochs. Guys, are you here? Are you getting the point? Yes. So you're getting the point, right? What I mean? We don't need to train the whole algorithm on 100 images. Instead, let's use the pre-trained models which have already been trained on millions of images, and let's reuse that. Okay, but there's a difference. Okay, but there's a difference. All right, yes, Nilanjana, that's the intuition behind that, but there's a difference. What we do is, okay, guys, understand this. Okay, so in deep learning, what happens, initially whenever we start training, okay, we start with some random numbers. Okay, we say that let these be the random features. Okay, we say point because at the end these are all numbers, right? So we say that 0.12, 0.13, 0.47, 0.57, whatever. Okay, instead of that, instead of starting with random numbers, what we can do is we can start with the features from the previously trained model, right? So whatever weights we had, okay, so whatever weights we had from the pre-trained models, those are called weights, okay, which the numbers I'm talking about, we can use them as the initial weights for our training purpose. Okay, so that is one kind of transfer learning. What does transfer learning mean? We are transferring the learning that we have got from the previous training thing to our existing approach, to our existing problem statement. Okay, but remember, for this you have to make sure that our existing problem statement and the previous problem statement should somehow be related or similar, right? You can't just do airplane versus some rocket when you have the pre-trained model on dogs versus cats. That's not gonna work. Okay, because dogs and cats, whatever we learn from there, you cannot reuse that for airplanes and versus rockets, because they are not similar, right? They are not similar at all. So Akshat is saying inheriting properties from them. Yes, it's kind of inheriting properties, but then it's more than that. Yes. So that's what transfer learning as a keyword means, that we are transferring the learning from the previously trained model to the existing approach that we're using. So guys, do you understand this point? Do you understand this point, guys? And trust me, you're never gonna train yourself on like whole data set from scratch. You're always, most probably always gonna use transfer learning, because so many researchers have trained different type of data set you know, whatever data set you talk about, they will have trained models about that. Okay, so whenever you go in an industry, you're usually not going to train any data set from scratch, sorry, any model from scratch. So that's not going to happen. Nilajna, no, Google Net is not the best. I think from the last time I checked, it's ResNext 101 or something. Uh, but mostly it's that, yeah. But it depends for which problem statement you're talking about. Okay, maybe for object detection it can be something else. For image classification it can be something else. So it depends on the problem statement or task in hand you have. Okay, so anyways, guys, let's start. So just let me know if you understand the intuition behind transfer learning. Is that clear to you? Is the intuition clear to you guys, that what is transfer learning? Guys, if you're yeah, apart from Nilanjana, whoever is here, please, if you can be responsive in the chat, it's gonna help me. But if you guys are busy with something, we can just start. Okay, but I'm gonna start anyways. Okay, I'm gonna start. All right, guys. So let me go to the code, right? So we're gonna do this in C++. That's the interesting part of it. Okay, and I'm gonna explain you the code line by line. Okay, so this is what we have, and you guys can read this out whenever you are free. Okay, I'm not gonna do it now because just saying things out loudly looks like a lecture or something. So anyways, we're gonna start, but how do we start? That's the important point. Okay, how do we start? How do we talk about pre-trained models? How what's the best way to start, right? So let's not start from there. Okay, let's try to read data first, because the first problem in hand is how do you read data set in C++, right? uh, so do you remember how to read an image in C++, everyone? Last time we did, right? CV IMRead. Yes, so cv2.imread in Python, and in C++ what do you have? CV scope resolution operator imread. That is it. So you remember how to read an image in C++, but how do you read all the images in a given folder using C++? That's the point, because what kind of data set are you going to have? You're going to have a folder. In that folder, you're going to have so many images, and you have to load all the images using Opencv in C++. So it's not just one image at a time. It's going to be we're going to pass the folder path, and we have to ask it to load all the images into a vector or something. Okay. So that is our problem statement. Hi, Anubhav. Thank you for joining us. Thanks a lot. Thank you, guys. Whoever is joining now, just let me tell you that tonight's stream is going to be a little shorter. We might do it for 30 to 45 minutes. I know it doesn't sound good, but then I'm not feeling well, so I'm going to stick to that. I don't really want you guys to have any negative vibes or something, right? So anyways, how do you read data? How do you read data from the location? So if you're here, just try to understand. Okay, I'm just gonna read this code loud for you guys to understand. So this function I made, which only reads one image at a time, and it converts this into PyTorch tensor. So Torch has a tensor class. Tensor, just try to understand that this is a particular PyTorch specific array class which is differentiable. That means which we can use for deep learning, for backpropagation, for learning, all the purpose, right? So you can differentiate, you can perform differentiation on this tensor class. That's why we're using Torch tensor class. Okay, and all right, so there's one thing about deep learning, that data set we have to make sure that all the images are of the same size. So if one image is of, let's say, 640 cross 480, and the other image is of 400 cross 400, it's not going to help us, right? So we have to make sure that all the images are of the same size. Okay, because the model will be getting trained on same size images, right? So the size that we are using should be similar to what the pre-trained model has used. Okay, just try to understand, guys. The features that the previous model has learned that we are using for transfer learning, the researchers decided that let's use 224 cross 224 cross 3. That means the width is 224, height is 224, number of channels are 3. Okay, the researchers decided to train 1 point something million images using that. Okay, using this size. Now whenever we are trying to get the learning from that model for our problem statement, we have to make sure that our image size is also equal to that which was used in the pre-trained model. Okay, so that is important. So if the researchers decided 224 cross 224 cross 3, we're going to stick to that. If they were deciding 1920 cross 1080 cross 3, we will have to use that. As simple as that, okay? So this size is because the model I'm going to use, they decided to use this size as the image size. That is it, okay? So how does this function work? So we have the return type is torch tensor. So whenever this function is called, it's going to return as a tensor object. Okay, that is why the return type is torch tensor, right? And what does it take? It takes the argument of a location. That means it's going to take the image path, single image path, right? Only one image path. Okay, and the problem statement is we have to try and load the data set. As simple as that. Okay, so let's try to do this. Okay, let's try to do this. How do you do this? So first of all, we have to read the image. As simple as that. So whatever location you were passed with, you have to pass it to CV IMRead function. One, because we're going to read the image as color, right? So we're going to have three channels for this IMG object, right? So CV mat IMG is equal to CV IMRead location comma 1. Then, as I told you that we have to resize the image to what it was used for pre-trained models. So we have to do 224 cross 224 resize. So again, the method is same. If you remember in C++, the second parameter is always the destination image. Okay, destination variable or what. So the first parameter is img, that is the source image. The second parameter is also img, that means whatever the resized image will be, it will be overwritten, right? So img now will be the resized image. Okay, guys, is it buffering for you? The stream is buffering for you. Is the stream buffering for you guys? I'm not sure. Let me know. Okay, Anubhav, that is a good question, to be honest. And I'm okay. Let me talk about this. Let me quickly talk about this after this function. Okay, Anubhav, I'll answer your question. Okay, after this function. Right. So once you have resized the image, okay, you have resized the image to 224 cross 224 cross 3. The next step is to convert the image, that is the CV mat object, to torch tensor. Okay, understand this, guys. There are two different types for the same image. Opencv uses CV scope resolution operator mat. Okay, PyTorch uses torch scope resolution operator tensor. So we have to convert from mat to tensor, because at the end we are operating everything on PyTorch. So it's going to use the PyTorch variables. Okay, right? So we have to convert this into PyTorch tensor object, right? How do you do that? There's a function called from blob. Okay, it takes the data from the image. Okay, so how do you do that? So okay, go word by word. Okay, so torch scope resolution operator from blob, the first argument is going to be the data that is coming from image img variable. Okay, so that's the object, that's the image we had. We're going to take that data, that is the array values. Okay, all the pixel values, and we are passing the size of it, just to let the tensor know that the image is of this size. Because see, when you're passing the data, it doesn't really know about the size. So you have to tell it explicitly that image.rows comma image.columns comma 3. Okay, what will be image.rows, guys? Will it be width or height? Can anyone tell me what will, if you know the number of rows, what does it mean? You know the width, or you know the column? Come on, it's easy, guys. Come on. If you know the class has a space for 10 rows, then what is it? Is it the width of the class? By class, I mean like in the schools, right? We have a classroom. So we know that there can be 10 rows. That means it will be height. Yes, that's really nice. Okay. So we are indirectly passing height comma width comma 3. Okay. And if you remember, that's what we do in Opencv as well. Right. And can anyone tell me why we are using torch k byte? Anubhav, that's gonna be height. That's going to be height, Anubhav. Just imagine 1, 2, 3, 4. If you know that there are 4 rows in a classroom, that means it's the height of it, right? Yes, Anubhav. Can anyone tell me why are we using k byte here as a class? So I'm going to explain this. So the type of the tensor will be byte. The data type of the tensor will be byte. Whatever the values will be stored, it will be in the form of bytes. So what does it mean? Come on. The values are of bytes. 1 byte is equal to how many bits, guys? 1 byte is equal to how many bits? 1 byte is equal to how many bits, guys? Come on, anyone? 8 bits, right? Dakshita, that's right. Okay. Now you tell me, okay. So for 8-bit value, that means it's going to vary from 2 power 0 to 2 power 8 minus 1, right? No, sorry. If, yeah, no. It's going to vary from 2 power 0 to 2 power 8. Yes. So what is going to be? 1 to 255. So the values can vary, sorry, 0 to 255. So it's going to vary from 0 to 2 power 8 minus 1. Yeah, I think it's buffering. Let me change, guys. Okay. Is it buffering? Okay. Just give me a minute, guys. I'm gonna change a few settings if that helps you out. Or should we stick to this? I will have to check if it's buffering or not. Okay, let's do 3000 kbps only then. Okay, if it's this should not buffer now, okay, because I just reduced the bits per second, whatever which was being passed. All right, guys, so this should be all right now, and I hope there will be no lag. Pratik bhai, good evening. Yeah, good evening. Thanks a lot for joining. Thank you. Right. So I was talking about why we're using kbyte here, because a pixel value varies from 0 to 255, right? So to represent a pixel value, we need a byte. Yes or no? Because it will take 8 bits, right? So to represent a pixel value, we need kbyte as the data type. That is it. Right. That's really nice. That's nice. So you guys got the point. Okay. So what are we trying to do here? We are trying to convert image.data. That means whatever data we had in the image img variable, we are trying to convert it into a tensor class. So we have done it here. Okay. So whatever this line, this 1, 2, 3, the third line of code, torch tensor img underscore tensor from blob, this function is doing, is trying to convert that into a tensor, right? So once this is done, all we have to do is now what? Permute. Is it still buffering, Mohit? Is it still buffering? Guys, is it buffering for you? It should not buffer now. Is it buffering for you now? Okay, Mohit. All right. No, na? Right. Okay, no issues then. All right, so okay, let me tell you this. In PyTorch, whatever the type, like whatever the format is, it's always channel first. Okay, so this is what we are doing here. That means whatever the third element, that is 2. So arrays start from 0th index, right? 0, 1, 2. So the 0th is what? 0 can be a height, 1 is width, second is column, right? So 0 is, again I repeat, 0 is height, 1 is width, second is number of channels. So the exact format how to represent that is what? Channel first. So we have to permute this. That means we have to rearrange in this way that the channels should be in the first position, then should be height, then should be the width. Okay. So this is what's going to happen here. Earlier we put 3 here. That means it was in the third position. So we brought it to the first position by doing 2, 0, 1. Dakshta, because bytes, they have been programmed to use bytes, right? Uh, and we can of course use other encodings, but we have to work in the way PyTorch has been developed. So they prefer bytes for some reasons. So we have to use bytes for sure. So I actually tried with kfloat or something, but that didn't work. I tried with different data types as well, but the using kbyte was only working. So I had to use that, right? So it's just the way PyTorch is developed. It prefers the data type to be really exact about what the range can be, 0 to 255, right? All right, guys. So this is what we are doing to read data from one single image. Okay. So let's try to code this out. Okay. Let's try to code this thing. The only problem is I don't have. So let me do this. All right, so I'm just gonna quickly install Opencv for C++. I'm not building from source. I'm trying to install the library for that. This should probably work, and we should be good to go. Right, so I'm just gonna use my cmakelist.txt, guys. So if you remember, whenever we are using Opencv in C++, it's preferred that you use cmakelist.txt. So if you're curious, by the way, you can go to this repo. I can share the link again for the cmakelist.txt. Okay, you can refer to this code. Okay, and this will really help you to understand what's happening. Okay, all right, so let's go here. All right, so I have my cmakelist.txt written over here, but right now it's only trying to find torch, but we have to also find Opencv, right? So all I can do is I can just copy this code, okay, and replace this. Okay, whatever I had here, I can just replace this. So I can just delete this thing and copy what I found from GitHub. Okay, and I'll explain this. Okay, do not worry. I have 4.4. No, okay, let's stick with 4.1 for now. OpenCV include DIS. Okay, I'm gonna explain everything of it. Okay, do not worry. So let's first try to run this thing before I start explaining you guys, because that's the right way to do that. So if you remember, how do you pass the path of what libtorch that we downloaded before, right? So you have to use this cmake prefix path as the flag, and you have to compile. So this actually compiled. Okay, this actually got compiled, and it also found OpenCV, which is nice. Okay. Oh, sorry. Sure, Yatharth, sure. Oh, I zoomed in a lot. This is better. Let me know at any point of time if my face comes in between the code. I can just drag it down. Okay. In fact, let's do it now. Let's try to not bring my face in between the code. This is better. And then of course, since I'm not that good looking, so I can just minimize myself a bit. Nice. This makes sense. Okay. All right. So this should solve a lot of problems now, Yatharth. Is it better now? Is it better now? Yep, nice. Okay, so we have configured the CMake thing. Now all we can do is make. Oh my god. Oh my god. Oh god, you need to stop. What happened? Wow. Look at the errors, guys. Come on, it's going to be really easy now. Do not worry. So just saying string is not a member of C10. So that's the problem. Am I trying to print something here? So should I also import IOStream here? I think that was the problem. Let's do CMake again. Let's do make again. What you need? There was some error that I found. What does it say? Guys, look at the errors. Let me just reset and try to run this code again. Okay. STR is not a member of C10. I see what's happening. C++ 14 or later compatible is required to use PyTorch. You need C++ 14 to compile PyTorch. All right. So in cmake list.txt, what we need to do is, you need to, I think this should work. Else, I think Dakshta is right. We have to use a different form of that. But let me just try this. Got it. Okay. No. So guys, whenever you're debugging, okay, whenever you get an error, always do this thing. Go to the top. Okay, by the way, it ran for me, okay? For those of you who do not know, who cannot see, I just zoomed in for you guys. So now it got compiled successfully, okay? So whenever you are debugging, always go to the first line of the error, okay? So what I did was I went to the first line of the error and it said error C++14 or later compatible compilers required to use PyTorch, okay? So now I know that what happened. What happened actually was in the cmake list.txt, I had 11 mentioned here. So I was using the C++11 version, okay? And it was saying that you need to have at least C++14 compiler. Why? Because PyTorch is using some of the things from C++14 in its source code. That's why it requires us to use C++ minimum version 14. Okay, so what we have to do is we just have to replace 11 with 14 and that is it. So here we are setting the CXS standard, that is C++ standard should be 14. So now even like C++20 is there, C++2b is also coming, I think. So it's pretty interesting what these guys are doing, but then at the end, let's try to run the code right. So it's the simple code of identity matrix, right? It's trying to give you a 3 by 3 identity matrix, that is it. Okay, so let's do this thing. Let's try to also import Opencv and okay, let's try to use command line arguments, right? So this RC is what? Number of arguments passed in command line. Okay, what is argv? So argv1 will be the first argument passed. Okay, what will be argv2? The second argument passed. Okay, so in this way RC and argv are organized. Okay, I just wrote this for you guys so that you remember and you keep seeing this thing, okay, in front of your screen. Like for example, what I'm going to do here is let's just print argv1. Okay, and let's just say the first argument is, by the way, the first argument will be what? argv0. Okay, because in the indexes start from 0. So argv1 is going to be second argument instead and argv2 is going to be third argument instead, right? So argv0 will be the first argument, argv1 will be the second argument, argv2 will be what? Third argument. So let me just print it for you, you guys will understand. Okay, so what I'll do is I'll just make again, okay, and it's gonna compile the code again because I changed a few things in the code. So it also ran the configuration thing because I also added import for Opencv, right? So let's run this code. Okay, so let's pass something push. What happened? What happened? Why didn't it run? Make clean. Oh, now we have example, right? So let's do not example push. So guys, understand this. So do you see what happened? If I passed push, it gave me the first argument is push. It's actually, by first I mean the index first, okay? So here I could have just passed pushashva, right? And if I will pass nothing, then it will give me nothing, right? So this percentage means we didn't have anything there. Okay, it was empty, right? Right, so now you know that whatever argument you're gonna pass is the next parameter after dot slash example. It's gonna be our image path, okay? Let's just say, so let me also just this is some Vim properties I always prefer. Okay, also nice. I was just reducing the number of spaces for my lines of code, so now it is like really better. So this is something like Vim kind of configuration thing. Okay, so let's do this. Std string image path is equal to argv1. That is it. So this is going to be our image path. Okay, so this is going to be our input image path. Now let's read the image. Okay, how do you read an image? CV scope resolution operator mat img is equal to CV scope resolution operator im read. What's going to be the first argument? Let's remove the comments from here. What is it going to be? That is it, right? So we are reading the image as the colored channel image, right? And how do you go further? So let's just try to show the image first. So I'm gonna display the image to you guys, okay? So I'm just running the code again. I'm compiling the code again, and I'm gonna run that code. Okay, but this time the first argument is gonna be what? What happened? Oh, okay. I know what I did. So here instead of passing img underscore path, I passed img. So this is the wrong variable name, right? So I just need to make sure that I'm not making silly mistakes, and that's fine. Okay, whenever you see an error now, you go to the code. Okay, you try to backtrack. Okay, whatever is the point where you got the error, you read that line again. Most of the times it's just a silly mistake. Okay, undefined reference to cv I am read. Okay, now I know what is wrong. Okay, do you guys know what's wrong? I think maybe this is wrong. Let me just uh so I probably know what's wrong. Let me quickly try this thing. um so now this is an ABI error, I think, which Dakshita was talking about. So let me just download the cxs11 ABI file. If this solves the problem, then this a really nice example that how this ABI thing can come in to picture, right? And I'm just 7 seconds away. By the way, how many of you here can you say hi in the chat, guys? 11 watching at least. See, we are almost done. We're just gonna continue this for 10 more minutes. We're gonna talk through this code, and that is it. So guys, I'm right now replacing what I had as LibTorch. I'm just changing the ABI version. That is, I'm just trying. I'm not very sure if this will work. Pratik bhai, you're here. That's nice. cxs1 ABI. I'm just gonna copy this here. I'm gonna. Okay, I'm just extracting that file. Okay. Guys, if you're here, please like the stream as well. I know tonight is going to be a really short stream, so we might not have that statistics like before, but then it's fine. YouTube is a race where I don't want to be. I'm just doing it for you guys. That is it for now. Let me just see if this works. Okay, I'm not very sure if this will work, but I'm just experimenting. Okay. Okay, so this time it compiled successfully. Last time it was not compiling successfully. All right. So let's just pass a path of it, like pass a path to it. YouTube we had, portrait bouquet we had, a sample. We didn't have any image, sample.png. Right. There you go. So there you go. Now this is working, right? Dakshta, there's a, when you're trying to build Opencv with source, right? So there's a flag that you can use whether to enable ABI or not, right? Or you can just figure out if Opencv was built without or with ABI and then try to download the LibTorch corresponding version for that. Okay. So we just changed the LibTorch version, guys, and we got the thing working. Okay. So that is it. So what, like I solved this error in I think 2 to 3 minutes, but what happens is it took me a lot of time to understand what's really wrong. So I've been doing this for a while now. So I used to get error whenever I try to install a new operating system. So I change my operating system every 2 weeks or 3 weeks, okay? Just for fun, right? So I love playing with operating systems. So whenever I install a new operating system, I build OpenCV again and I face these problems. So with experience, I learned this thing that, okay, you need to try and figure out what is the ABI problem and all that, okay? Anyways, so we can see the image, okay? Let's try to convert this into, so right now our target is to try and convert CV mat object to torch tensor, right? So how do you do that? First you have to resize the image, okay? Okay. So let's resize the image to 224 cross 224 cross 3, right? So how do you do that? CV resize. I hope it's resize and not I am resize. No, it's resize only, right? Let me quickly go and check. I sometimes you just forget because there's so many functions. It's resize only, right? Okay. That's it. So we are just saying that resize the image to 224 cross 224 cross 3. And that is it. You don't have to pass a channel. It will automatically take it from the input image that you have, the source image. That is it. Okay. Then convert into a torch tensor object. How do you do that? You use from blob img.data. Then you have to pass the size of it, img.rows, img.calls, and we had channel as 3. And what else did we have as the last parameter? Did we have any other parameter? Yes, the type of it, right? So it's going to be torch k byte. That's it. Okay, that is it, guys. So from here we can convert a CVMat object to what? As you can see here, we had used the same method, right? So we are just rewriting that. Okay, and then what's the next step? We have to make sure that the channel is the first in the shape, right? So what we have to do is we have to rearrange the tensor to be in the format of channels first. So what we're going to do is torch, no, what is it? Okay, sis, sorry, forgot, guys, sorry, okay, but that's fine. You don't really need to remember everything. That's completely fine. You can do that. Okay. So we have to permute and we have to say the new, so second index, that means it was channels, right? Channel 3 means channel 3 means it is BGR, right? So we have 3 channels, red, green, blue. Grayscale has one channel, only one channel. You understand now? So now as you can see, the second index was what? 0, 1, 2. So this was 3. So now this will be what? So the shape will be what? 3 cross height cross width. Earlier, what was it? Now, earlier, it was what? Height cross width cross 3. That is it. So I hope this is clear to you now. Okay, just trying. So this looks far beautiful now. So whenever you write codes, you need to make sure that you write comments. You write really good and beautiful codes, and the variable names should be really understandable, right? So here we have converted the what? The CVMat object to image tensor. And if I just do, I don't know if this is gonna work. This is gonna work or not, but let's try. So I'm just trying to print the tensor to the console. That is it. So earlier it worked for an identity matrix. Whenever we did std cout, it worked. Okay, but let's try and see if this works for a mat object, right? So I'm gonna do example, and I'm gonna pass the sample.png path. Oh, nice. So guys, do you see this thing? So we have 3 comma 224 comma 224. As you can see, the channels is first, right? And these are the pixel values. So this is the image we have, but this time in form of what? A tensor. So you can see there are 224 columns. They're gonna be 224 rows. So it's gonna print all of that for you. So these are the pixel values that we have in the form of tensor, right? So this is a whole tensor class that has been printed to the console. Okay, that is it. As simple as that. But what we're gonna do in the next stream is we're gonna convert this into a function, right? Let me quickly reindent it. Nice. Or this sounds better. No, the previous one is better. Okay, let it be. Okay, let it be. All right. So do you guys understand what we have done so far? Yatharth, Anubhav, I'm going to take your question now that why are we not using namespace? But let me know if you're here so that I can answer your query. Dakshta, Yatharth, Mohit, Pratik Bhai, is everything clear to you till this point? Whoever is here, is everything clear to you till this point? Come on, guys. Yes. Let's say yes or no. Yes. Okay. All right. All right. Yes. So Anubhav, you are here. All right. So I'm going to take your question now. All right. So the question from Anubhav was, if we would have used here in the top only. Oh, what I'm sorry. if I would have used using namespace std using namespace cv. So everywhere I'm writing std string, right? So I don't have to use this namespaces, right? So I can surely remove these namespaces. That is it. So this is what Anubhav is trying to say, right? But what happens is, whenever you're using namespace, now you do not know from where did this tensor came from. Sorry, from where did this tensor come from? So you do not know that tensor is from CV or std. Okay, so whoever is new to C++, whoever is new to PyTorch, he does not really remember, because he doesn't know that maybe tensor exists in CV, maybe tensor class exists in std namespace. Okay, so he is going to be real confused. Okay, but also one more thing is, sometimes it just happens that CV also has a string variable, sorry, string class, no, not class, a member or a data type or something, right? And std also has string, right? In these times when you are using namespace, so the compiler, like, I mean, especially the user will not know whether string is from standard namespace or CV namespace, right? Right, guys? So do you understand this thing? It's still buffering, right? I'm really not sure why. We can check that out, but then, so you guys understand what's really wrong with using namespaces? So whenever I'm writing code, I never use namespaces. Okay, I mean, I never avoid using namespaces. Okay, so this is a good programming practice to stick with basics, to try and use namespace scope resolution operator, so that we know from where did it come from. Okay, right. So I hope this is clear to you. We have one question, I think, isn't this supposed to be bit values? Dakshta, but when you are printing now, when you are printing to the console, it's going to print as an integer or a byte type. Okay, it's at the end, it's a byte type, right? So 8 bits is combining that to an integer and just showing that to us. Okay, by using byte, all we are trying to say is the range can vary from 0 to 255. So the memory allotted to it is really less. So we don't waste a lot of memory, right? So, but what we would have done before is, if we were using int64 bits, so 2 power 0 to 2 power 64, maybe something like that. Okay, so it's going to be really memory wise, it's going to be really extensive. So that's why we are using bytes only, right? We only need 8 bits, so we're gonna only use that memory. Pratik, not entirely, but I can surely understand what you're trying to do. My C+ is going to take time. That's fine. That's fine, Pratik. Bhai. That's completely fine. Dakshta, this is not implicit conversion. This is still a byte type. Again, I'm saying, see, every integer is represented in bits, right? Whatever, like maybe integer you're trying to represent int 64t is equal to. Okay, let me show you this. So you could have done this as well. Int 64t x is equal to 3. This is gonna take 64 bits, but when you print, it's an integer, right? Anmol, this is Ubuntu 20.04. And thank you for joining, by the way. It's 20.04, right? So I have to update my nightboard commands as well. I'm really sorry I didn't do that. So I'm going to update that as well. But for tonight, guys, that was it. So we did a few of these things, like we tried to read an image and convert that to a tensor. So we are trying to take it slow. Tonight was not a good stream maybe for you guys, but I hope you learned something from here. So I'm not going to waste your time by talking a lot about myself, or what's up and all that, because that will not be good. Let me just quickly shift to chatting mode. Right, guys? So I'm not really going to waste your time. Whatever we did tonight, I hope it was really helpful to you, and we will keep doing all these things. I'm going to release a lot of videos in upcoming time. Okay, that's going to happen for sure. So just let me know if this sounds good to you. If you have anything to say, Anubhav, thanks a lot. Thank you. if you have anything to say, please go ahead and type in the chat. And guys, we are not getting enough subscribers nowadays. Can you please refer this to your friends? We have just moved one in past 2 days, even while we are streaming. So I know it's my job. So if you guys feel like you should not share, then it's okay. I will have to do marketing and all. Uh, thank you, thank you, Anmol. Thanks a lot. Yeah, thank you. It means a lot. Yes. I guess everyone out here is a pure heart. Come on, you are also good, right? So God bless you all. Okay. Uh, so please share it with everyone if you can. If you cannot, that's completely fine. It's my job to do that. So again, I'm saying I'm not really focusing in the YouTube race for now. Whatever is happening, I'm gonna let it happen naturally because this is not my profession. I'm doing it for you guys and for myself as well. I just feel good by sharing things. Uh, so that is it for tonight, guys. I'm gonna go and have thoda rest. Thoda sa rest. Probably. I'm not sure. I have some work as well. So I'm really sorry, guys, if I was not able to satisfy your expectations tonight, but that's life. That's life. I'm sorry. All right, guys. God bless you. Please say Gunni in the chat. We couldn't do GitHub Raid as well. I need to edit the YouTube title later on. Sure, sure. Great, guys. Take care. If you can just type Gunni in the chat, it will give positive vibes to everyone. So maybe I was not able to smile all the time, but I'm really sorry. God bless you, everyone. Stay happy, stay blessed. Prabha, ਤੁਸੀਂ ਜਾ ਰਹੇ ਹੋ, ਤੁਸੀਂ ਮਤ ਜਾਓ. ਅਸੀਂ ਇੱਥੇ ਅਭੀ ਆਏ. That's fine. Yeah, you can always have rest, right? You can always have rest in later in life, right? Let's just work for now. No, I'm just kidding, guys. Come on. Have rest, and God bless you, everyone. Prabha, thank you for joining. Thanks a lot. I'm really sorry I have to leave now. I'm just a little stressed out. But then God bless you, everyone. Take care. Thank you for being there for me in the YouTube, right? You were here for 1 hour. For some people don't even know what's happening. But then this is such a beautiful thing that you guys are doing for me. Thank you, guys. Take care. Guni, Pratik Bhai, Guni, Prabha, Guni, Dakshta, Guni, Yathat. Good night, Gunni. Gunni Anubhav, good night. Take care, guys. Bye bye. See you out. Yatharth Gunni, yaar. God bless you.